Fermented foods represent a living bridge between diet and deep cellular renewal, particularly through their influence on the gut-liver autophagy axis. At first glance, these foods, sauerkraut, kimchi, kefir, natto, miso, and fermented vegetables, are celebrated for their probiotic content. But beyond the beneficial bacteria themselves, these foods are potent autophagy activators because of what those microbes produce. Vitamin K2, B-complex vitamins, and a spectrum of bioactive metabolites that modulate inflammation, enhance mitochondrial performance, and improve gut-liver signaling. Together, they create a dynamic biochemical environment that supports autophagy not just in isolated cells, but across entire systems of detoxification and renewal. One of the most impactful compounds produced through fermentation is vitamin K2, especially in its -7 Malawian-Quatches and -4 Malawian-Quatches forms. While vitamin K1 from leafy greens supports blood clotting, vitamin K2 plays a more regenerative role, guiding calcium into bones and out of arteries, modulating inflammatory responses, and influencing mitochondrial function. K2 also shows increasing relevance in supporting autophagy by protecting cellular membranes, particularly in gut epithelial cells and hepatocytes. This protection ensures lysosomes, the final degradative chambers of autophagy, can maintain their acidic environment and continue processing cellular waste efficiently. In tissues under constant metabolic load, like the liver and intestinal lining, K2 appears to reduce stress-induced damage while promoting regenerative cycles that depend on intact autophagy. At the same time, fermented foods are rich in B vitamins, especially B1 thiamine, B2 riboflavin, B6, and B12, all of which are essential cofactors in mitochondrial metabolism. B vitamins act as ignition keys for the Krebs cycle and electron transport chain, allowing energy to be produced cleanly and efficiently. When mitochondria work well, fewer oxidative byproducts are released, reducing the cellular damage that would otherwise trigger desperate, excessive autophagy. This maintains the cell in a balanced state, ready to clean when needed, but not overwhelmed by debris. Furthermore, B vitamins such as B12 and B6 play roles in methylation and homocysteine regulation, both of which affect inflammation levels and mitochondrial health, key factors in determining whether autophagy can proceed smoothly or becomes blocked. But perhaps most compelling is how fermented foods activate this process, not through isolated nutrient delivery, but via a full-spectrum microbial ecosystem. The beneficial bacteria in fermented foods produce short-chain fatty acids, SCFAs, like butyrate, acetate, and propionate during fermentation of dietary fibers in the gut. Butyrate, in particular, has been shown to directly induce autophagy in colonocytes and liver cells. It helps close the gap between the gut and systemic health by sealing the intestinal barrier, reducing leaky gut conditions that would otherwise trigger low-grade systemic inflammation, a major inhibitor of effective autophagy. In this way, fermented foods help protect the very environment in which autophagy must operate, the interface between the gut, bloodstream, and liver. This gut-liver signaling is especially important in maintaining systemic detoxification. The liver relies heavily on autophagy to recycle worn-out mitochondria, neutralize reactive oxygen species, and clear environmental toxins. When the gut microbiome is healthy, fortified by the regular intake of fermented foods, it sends anti-inflammatory signals that help the liver maintain efficient autophagic recycling. In contrast, when the gut is inflamed or dysbiotic, it releases endotoxins that burden the liver and suppress autophagy, accelerating cellular aging and disease risk. Fermented foods help shift this entire landscape toward one of calm, repair, and readiness. They do so not by overpowering the body's systems, but by harmonizing with them, nudging the internal environment into a state that invites natural restoration. The result is a kind of metabolic clarity. Cells begin to sense that their environment is safe, well-supplied, and regulated. Under these conditions, autophagy becomes more than just a stress response. It becomes a routine part of maintenance, like cleaning a house not just when it's dirty, but regularly to prevent buildup. Fermented foods support this rhythm beautifully. Their live cultures, vitamins, and signaling molecules nourish the microbiome, protect gut integrity, reduce systemic noise, and elevate the liver's ability to quietly, efficiently renew itself. In the broader context of aging, inflammation, and disease prevention, fermented foods offer a model for how food can become a daily therapeutic. Their influence on the gut-liver axis demonstrates that autophagy isn't something reserved for fasting, stress, or pharmacological intervention. It can be gently cultivated, meal by meal, through foods that deliver not only nutrients, but living intelligence. This positions fermented foods as not just digestive aids or probiotic sources, but as functional elements of a longevity-focused diet, capable of supporting the body's deepest systems of cleaning, communication, and renewal.